Let's have a closer look to the article Understanding and Misunderstanding of Randomized Controlled Trials, RCTs, by Nobel Prize winner Angus, Deaton and co-author Nancy Cartwright. It's a 2016 article. It wasn't published in a leading journal, so this is just a discussion paper version. So Deaton has also written papers with Duflo, for example, but he has and of course also his co-author has a critical view on RCTs, saying that they are a little bit oversold. It's not like that they are a magic bullet. It's not like that this is a panacea that can solve all problems. And what in fact those authors are doing, they have two challenges. The one is on internal validity, saying this might be an issue, and second, with respect to external validity. So can we learn something for other sites, for other countries, for other regions, or more generally spoken, do we learn something which is independent on institutions? So Deaton is of course a well-experienced researcher, so he is absolutely familiar with the NIT RCTs in the 60s, and there was a kind of RCT winter, if I might steal the idea from the AI winter. So it was a kind of frozen period where RCT were received less attention, and this was more in the 70s and 80s. But then afterwards, it turned out that RCTs became more popular. Once again, all the RCTs were summarized by Greenberg Schroeder and in the 2004 volume. And especially with the development of developing economics, right? RCTs became more prominent. It's about the what works approach here, and I shared a famous paper in that world, in the development economics world, with you, referring to the panacea, Duflo and others paper, 2015 paper on the bundle that might work to end or at least to reduce poverty. So as I already said, it's about internal and external validity, and their message here is, so be cautious with respect to the RCT results. Popular interpretations might be misleading, and misunderstandings might lead to wrong policy recommendations. So to highlight 5 misunderstandings. First, that randomization ensures a fair trial by ensuring that, at least with high probability, treatment and control groups differ only in the treatment. So this is an argument that there are always something, there's always something that is unobservable, right? It's always something that hides in the error term, that hides in the epsilon, right? And even if you have rich data, there's always something you cannot measure, but that does play a role. Simple thing is motivation, that is not very easy to measure, or just some other soft skills like conscientiousness or emotional stability. So there are always things that do matter but are hard to measure. That's the first point. A second point is that RCTs provide not only unbiased estimates, so they do really get rid of the selection bias and all the other biases that might play a role, but also that these estimates are precise. So that's what they challenge. A third point is randomization is necessary to solve the selection problem. So the idea is maybe we do not need randomization because we don't like it due to ethical issues, for example. And we could have observational studies where we come up with artificially created control groups, and that might also be a valid way to identify causal effect. A fourth point is lack of blinding, which is common in social science experiments, does not seriously compromise inference. And a fifth point is that statistical inference in RCTs, which requires only the simple comparison of means, right? So the comparison of means is the difference in means of program and control group with respect to some outcome variable, and this is straightforward, and so that standard significance tests. So just to look at the standard error of the estimated regression coefficient is sufficient. So these are the 5 points. Let's have a closer look to them. So now let's come to the internal validity part of this paper. So they refer to Fisher's agricultural RCTs in the 30s, and since then it's well known that individual treatment effects are not observables. But because we have the fundamental evaluation problem, and you can only observe one person in one state, and the other state is then the so-called counterfactual. So either you observe an individual as a participant in a program, then the counterfactual is the potential non-participation, or you observe an individual as a non-participant, then the counterfactual is the potential participation in the program. Now I already used the term potential, so potential outcome approach will be an issue in the next session, not in this session. So in individual treatment effects are in principle unobservable. That's what we know. And we also know that the basic theorem governing RCTs is that the average treatment effect is the average outcome in the treatment group, right? That's the average outcome. That's the average outcome in the treatment group. If you sum that up, right, over all participants, minus the average outcome in the control group. So minus the average outcome in the control group. And that's the ATE hat. So that's what you can estimate. Therefore the hat, right? The ATE hat. It's not the ATE, because the ATE is that you have the mean outcome of the program group, that's this guy, minus the potential outcome of the program group had the program not participated in the program. So that's the ATE, and the ATE hat is what you really can observe in the data. Or in words, the estimate of the average treatment effect, the ATE, that's now not so beautiful, but the ATE hat is simply the difference between the means in two groups. And this difference in means is an unbiased estimate of the mean treatment effect, so of the ATE without a hat. Okay, just to make clear that we really got that. So the basic theorem tells us that the difference in means is an unbiased estimate of the average treatment effect, but says nothing about the variance of the estimator. So this will play a role when we talk about machine learning. So the bias variance relationship. And here you have already something that refers to the mean squared error. That is one measure of the distance of the estimate from the truth. So it could be that a biased estimator is a better one, which is closer to the truth, and that's the point that is made here. So precision and bias is here in the core of this paragraph. So one way to assess closeness of an estimator to the truth, right, is the mean squared error. And that's something we'll need in future lessons. And the mean squared error could be reformulated, or could be rewritten in a way that we have two parts. And the first part is the variance, and the second part is the bias. And the point that is made here is that the difference between the estimate and the truth measured by the mean standard error does not only depend on the bias. And if an RCT makes the bias 0, right, then this one here disappears. However, the variance still plays a role. And so the crucial point here is that it's certainly good to have a 0 bias. However, still the variance might drive the result, and if the estimation is far from truth, then you're running into a problem. So focusing on unbiased results is misleading, and the point is that an unbiased estimator that is nearly always wide of the targets is not a useful one. And therefore we should also take the variance into account, and the variance is easy to measure via the standard error. So once again, the mean squared error has two components. In an RCT, you can get rid of the bias. What remains is the variance. We learn something about the variance from the estimated standard error, right? The standard error of a beta 1 hat. That's standard deviation divided by root n. And as we know, standard deviation squared yields the variance. So we learn something about the variation, the variance, and that's what we should be aware of. So unbiasedness does not solve the problem. By the way, this is something that will come back in machine learning. So because the first chapter in machine learning part will be that it's about trading between unbiasedness and variance. So getting more precision. So there's a trade-off right here between these two guys, and the question is, how could we solve that in a good manner? So one interesting point is with respect to t-tests and the comparison of distributions that rely on standard t-tests. So what is well known, if you compare two groups and you assume a t-distribution or normal distribution, and then you have the mean outcome of these two groups, the program group and the control group. So if this is this t-distribution or normal distribution, then it's fine. However, what we know is if a distribution is in fact a skewed one, for example, right skewed, like a typical income distribution, right? Or wealth distribution. If this is the case, then the comparison of two means is not correct, and that might lead to wrong results. Well, I think this is an interesting point, which is described here in more detail. Another point is the outlier issue, right? We know that the mean is sensitive to outliers, and the median is not sensitive to outliers, right? So if you have an outlier, then the median is unchanged, whereas the median is unchanged, whereas the mean goes up or goes down depending on which side the outlier lies. So just to make it clear, the outlier has an influence on the mean, and the ATE refers to the mean and does not refer to the median, right? So this makes the mean sensitive to outliers. And that's the second point that is highlighted here, so that outliers may drive the results. So you have to be careful with respect to that. And so it's always good to have the descriptive statistics in mind, right? And that's why we start with detailed descriptive statistics to get a feeling for the data set. And if there are a lot of outliers, which we can see in the box plot, right, then we should be careful with our basic assumptions. Well, I don't want to dig too deep in that issue, but just to make that point with the outliers once again. So if the outlier is in the program group, then you might measure a positive treatment effect, whereas if the outlier is in the control group, you might measure a negative treatment effect. So the outlier makes the result, right? And so we have to be careful with respect to the outliers. That's the main message. Another interesting point in this paper is blinding. Just to make that clear, in medicine, blinding is feasible. In social sciences, RCTs, blinding is not feasible. So typically, people know whether they get treatment or not. And that's clear in the social sciences RCT, whereas in medicine it's different. Okay. Having said that, then of course there are incentives for those who were denied access to the treatment and they would like to have the treatment, that they might find ways to get it anyway. That's what we call control group substitution bias that is going on, right? Or those who were assigned to the treatment but think, well, treatment really won't help me, right? That they do not comply with. So they're assigned to the treatment, but they don't take the treatment, right? And that's the treatment dropout bias, treatment group dropout bias. We have already talked about these two biases, right? And this is a result of the inability to do blinding in social sciences RCTs. And the argument that is made here is Then if this is the case, we should take a discussion of the exogeneity, the exclusion restriction more serious. So we will see that we will talk a lot about the exclusion restriction in case of instrumental variable estimations, but we don't do that in case of RCTs. We just think that that's not a problem, right? And that's the main point. So the section to internal validity ends with the insight so that RCTs may tell something about causality for different subgroups. So for example, the ATE focuses on those who were assigned to the treatment control group and really got the treatment, right? Whereas the ITT is for those who were assigned to the treatment, but for some reasons we have already discussed, they may not get the treatment, or they may not be excluded from the control from the treatment due to some other biases like control group substitution bias. And what we will understand in more detail later is the late effect, the local average treatment effect, that refers to compliers. So the overall message here is RCTs might help to identify causal effects, but only for some subgroups, and this is what we learn from the sample. And statistical inference says what do we learn for the population, and this is the basic for policy recommendation. So at the end of the day, it's not a fundamental critique of RCTs, it's just to make them better and to be more aware what could be done wrongly, right? Because there are people out there who just say, well, we have a randomized controlled trial, we don't need any theory. The only thing we do is we take the difference and means, and that's it, right? And that's what they are challenging. That primitive, naive view of RCTs that you just compare mean outcomes of a treatment, the control group, and say that much more is going on. So we have to be much more smarter as researchers to get out the truth of the data, and have to look very closely to what happens after having implemented an RCT and prior to an RCT. Is there any selection going on, right? So that's the main message. It's not a fundamental critique that we should not pursue RCTs anymore. No, it's something else. It can more feeling, and that's the message if we talk about internal validity. The second part of the paper is on external validity. Just assuming now everything has been done well with the RCT, it was not flawed, people got the treatment, we were aware of all the internal validity issues. So what are such findings good for? How should we use them? That's the external validity part of the paper. So an interesting example on how a causal effect works. So what is the, let's say, institutional environment that is necessary so that a causal effect really is identified? That's the Bertrand-Russell chicken example, which is provided here. That provides an excellent example of the limitations to straightforward extrapolation from repeated successful replication, right? So the bird infers based on multiply repeated evidence that when the farmer comes in the morning, he feeds her. So, right, that's the replication issue. So learning from replication. Okay, comes in the morning, feeds her. The inference serves her well until Christmas morning, when he wrings her neck and serves her for Christmas dinner. So the point is, the chicken is not aware of the institutions. So the chicken is not aware of Christmas. And having said that, this might transfer to other RCTs, where just observing behavior without knowing the institutional framework might lead to wrong results. So to translate the chicken example of 1912 into the real world now, of real world today. So conditional cash transfers cannot improve child health in the absence of functioning clinics. So you need the helping factors to understand why programs work, right? Policy targeted at men may not work for women. Or we use a lever to toast our bread, but levers only operate to toast bread in a toaster. So if we misunderstand the setting, that's the main message here. If we misunderstand the setting, so if we do not understand why the treatment in our RCT works, we run the same risks as Russell's chicken. And that's probably the most important point here in the second part of the paper. So this has also influenced two researchers like Duflo and Panacea. They did also joint papers with Deaton. We need to think through the causal chain that has generated the RCT result and the underlying structures that support this causal chain, whether the causal chain might operate in a new setting, and how it would do so with different joint distribution of the causal variables. So it's all about the why and thinking through that. Just to put this article into the context of the RCT discussion, so what the authors are saying is, let's not be naive and let's be aware of internal and external validity issues, and let's find out why a program works, and let's be aware that even if a program is several times positively evaluated, if you scale it up in another country, maybe if it's implemented by a government who is not really in favor of such a program, then this might lead to other effects and there will be also unintended consequences and that you cannot see. Well, it's just that you have a broader view on the issues and just do not believe in the simple results of RCTs. So it's if you say something works, right? What works? This message is, why does it work, and why maybe it does not work in different institutions.